Hello, everyone. Welcome back to the Rev Games Academy. Today, we are going to learn how to implement player movement and jump mechanics in a 2D game. As an extra bonus, we will also cover how to add animations for different player states like idle, running, and jumping to make the experience smoother and more engaging. So let's dive in. Before we start coding, we need to set up animations for our player. In the project window, you will notice multiple sprite images that we can use to create animations. Let's start by creating an idle animation for the player. To create an animation, first, select the player game object in the hierarchy. Then, drag and drop the sprite images related to the idle animation onto the player. Unity will automatically create an animator component and a new animation file. Save it as idle animation. Now that we have the idle animation, let's test it by click play. You will notice that the idle animation plays smoothly, giving our player a natural resting state. All right, next we need to add the run animation. To do this, go to the inspector, find the animator component, and remove the current idle animation. Then, in the animation window, drag all the running sprite images to create a new animation clip. Name this animation Run. Once done, click play and test it out. You will notice that the run animation is playing too fast. To fix this, select the Run Animation controller and change its speed from 1 to 0.8. Now the running animation looks much smoother and more natural. Similarly, let's create the jump animation. First, remove the run animation from the animator. Then, drag all the jump sprite images onto the player and name this animation Jump. When you play the animation, you will notice that the jump animation works perfectly and appears more realistic. Let's rename all three animator controllers to match their respective animation clip names for better clarity and organization. Now that we have successfully set up the idle, run, and jump animations, it's time to combine them and apply them to the player. Before proceeding, let's organize our project by creating a new folder in the project window and naming it Animations. This folder will store all our animation controllers and animation clips, keeping the project structured and easy to manage. Next, select the player and open the animator window. Drag and drop all the animation clips into the animator to set them up correctly. The first step is to define idle as the default state, which means the player will start in the idle position. To do this, right-click on the idle animation and select Set as Default. After that, we need to create transitions between animations. We will create transitions from idle to run and idle to jump, as well as from run back to idle and jump back to idle. These transitions ensure smooth switching between different animations based on player movement. To control these animations through code, we need to set up parameters in the animator. In the animator window, click on the Parameters tab, and then click the plus icon to add a new parameter. Select Ghoul and name it Run. This parameter will be used to determine when the run animation should play. If the run parameter is set to true, the run animation will be triggered. Similarly, add another parameter by clicking the plus icon, selecting Trigger, and naming it Jump. Unlike the run parameter, which can be toggled on and off, a trigger is activated once and resets automatically. This makes it perfect for the jump animation, as jumping should happen only when triggered. Now, let's configure the transitions. For the transition from idle to run, click on the transition line in the animator window, then go to the inspector window. Here, uncheck Has Exit Time, and then go Settings, Options, make it all values set to 0, and as we want to control this transition using the run parameter, instead of waiting for the animation to complete. Then, go to the Conditions section, click the plus icon, and select Run from the dropdown. Set it to true so the run animation plays when the run parameter is true. Similarly, for the transition from run to idle, uncheck Has Exit Time and set all inputs to 0. In the Conditions section, add Run but set it to false, ensuring that when the player stops running, the idle animation plays. For the idle to jump transition, select the transition and uncheck Has Exit Time and set inputs are 0. In the Conditions section, add Jump Trigger. This ensures that when the jump trigger is activated, the jump animation plays immediately. Finally, for the jump to idle transition, we will keep Has Exit Time enabled and adjust the settings so that the animation smoothly returns to idle once the jump animation finishes playing. Now that we have perfectly set up the animations, it's time to add movement and jumping functionality to the player while ensuring the animations play correctly through code. First, select the player game object, then go to the inspector window and click Add Component. Search for New Script, name it Player Controller, and add it to the player. Once the script is created, double-click Player Controller to open it in Visual Studio. Now we are ready to start coding the movement and jump mechanics while linking the animations dynamically. Now, let's start by declaring the necessary variables. First, declare a rigid body 2D variable and name it RB, which will be used to control the player's movement. Next, declare an animator variable named PlayerAnim to handle animations. Additionally, declare a float variable called horizontal to store the player's movement input. Let's create a function to handle player movement. Inside this function, store the horizontal input value using input.getAxisHorizontal. Then, check if the horizontal value is greater than 0.1 to determine if the player is moving. If the condition is met, update the player's velocity using rb.velocity equal to new vector2 horizontal multiply 4 rb.velocity.y. This ensures that the player moves left or right while maintaining the current y-wax velocity. Next, adjust the player's scale to flip the character's direction based on movement. If horizontal is positive, set the X scale to 0.7, and if it is negative, set the X scale to minus 0.7, making the player face the right direction. After handling movement, we need to check if the player is touching the ground, as jumping and running should only work when grounded. To do this, declare a bool variable called touchGround and a layer mask variable called groundLayer at the top. Then use physics 2D raycast into the fixed update function to detect whether the player is standing on the ground by checking for collisions with the assigned ground layer. Now, let's create another function to handle animations. Inside this function, declare a bool variable called isMoving and check if horizontal is greater than 0.1 or less than 0.1. If the player is moving and touching the ground, set the run animation parameter to true. Otherwise, disable the run animation, allowing the idle state to play. Now, let's create the final function to handle jumping. Inside this function, we'll write a condition that checks when the spacebar is pressed and if the player is touching the ground. If both conditions are met, we apply a jumping force to the player using rigid body 2D velocity. Next, trigger the jump animation by setting the jump parameter in the animator. Since jumping happens instantly and doesn't require a continuous state, use animator.setTriggerJump instead of a bool condition. Finally, call all three functions, handle movement, handle animation, and handle jump, inside the update method. Save the script, go back to Unity, and test the movement and jump mechanics. Before testing the player movement and jump functionality, we need to assign the rigid body 2D and animator references and set up the ground detection layer. First, select the bottom collider in the hierarchy. At the top of the inspector, you'll notice a layer dropdown. Click on it, select Add Layer, and create a new layer named Ground. Once the layer is created, go back to the bottom collider and assign the newly created ground layer to it. Next, select the player and open the player controller script in the inspector. In the layer mask field, set it to ground so that the script can detect when the player touches the ground. Now that everything is set up, click play to run the game and check how the movement and jump mechanics work. Here, the flip is not working properly. I might have made a mistake in the code. Let's go back to Visual Studio and check. You will notice that instead of using sine, I mistakenly used sin. That is causing the problem. So I'll change it, save the script, and test it again in Unity. Yes, that's great. Now our player is moving and jumping with proper animations, and it looks pretty cool, right? The movement feels smooth and neat. And that's it for today. In this tutorial, we successfully completed the player movement and jump mechanics, along with the animation setup. However, you might have noticed that if the player moves outside the camera view, they are no longer visible. This happens because the camera is not following the player. So in the next tutorial, we will set up the camera to follow the player smoothly. Don't forget to like, subscribe, and drop a comment if you have any questions. See you in the next tutorial.